Physical and chemical changes. The sun rises, the night turns into a day, the seasons change, the leaves shed, flowers bloom, and living beings grow. Every day, we see a number of such changes happening around us. Change is inevitable. It takes place all the time and everywhere. However, changes differ from one another in a number of aspects. Some changes are fast, others are slow. Some of them are temporary, others are permanent. Some are periodic, others are non-periodic. Some are natural, others are man-made. Some are reversible, others are irreversible. On the larger front, a change may be categorized into a chemical or a physical change depending on how the properties of a subject alter when it undergoes the change. Physical change. It is a change in which substances undergo changes in their physical states, such as shape, size, color, and state, and no new substance is formed. Physical change is reversible and temporary. Characteristics of physical changes. These are reversible changes. Physical changes are temporary. No new substances are formed. Energy, as heat, light, and temporary, is not emitted. Examples of physical changes. Understanding physical changes by some examples. Folding and unfolding of a paper sheet is a physical change. No new substance is formed in this change. You can get the paper back by unfolding. Stretching of a rubber band is a physical change. In this change, only the size of the rubber band changes. The rubber band comes back to its original shape and size once it is released. This is a physical and reversible change. Melting of wax is a physical change. In melting, only the state of the wax is freezed. It can again change into solid form, so it is a physical change. Chemical change. When two or more substances react chemically to form new substances with different properties, is called a chemical change. This occurs by chemical reaction. In a chemical reaction, substances which react are called reactants, and the one which are formed are called products. Chemical change is irreversible. It is accompanied by either absorption or evolution of heat or energy. In these reactions, heat, light, or sound may be produced. There may be change in color or evaluation of gas during reaction. There are many chemical changes that take place in our body at every moment and every day. Due to these, we get energy, grow and undergo various age-related changes. For example, the food we eat, breathing, digestion of food, respiration, etc. Some other examples of chemical changes are rusting of iron, formation of calcium carbonate, burning of magnesium ribbon, etc. Characteristics of chemical changes. A chemical change is permanent. A new substance is formed. Forms of energy such as heat, light, or electricity may be emitted or absorbed. A chemical change is irreversible. Let us understand the chemical change with the help of some activities. Change of color. In a chemical reaction, the color of reactants change. Evolution of gas. In a chemical reaction, when one of the component is liquid or in solution form, then sometimes gas is evolved in the form of bubbles called effervescence. To know that gas is released during a chemical reaction, put some baking soda, sodium carbonate, in the test tube and add vinegar to it. You will see bubbles coming out from it. It is a carbon dioxide gas. Pass the gas through lime water. Lime water turns milky due to the formation of calcium carbonate, which is a white substance insoluble in water. Vinegar plus baking soda gives carbon dioxide plus water plus other products. Carbon dioxide plus lime water gives calcium carbonate plus water. Change of state. The change of state in a chemical change is not reversible. To find out the change of a state in water, When electric current is passed through water acidified with a few drops of sulfuric acid, it breaks to give hydrogen and oxygen. Water is a liquid and hydrogen and oxygen are gases. Therefore, it is a change of state which is not reversible. Water, liquid, under the action of sulfuric acid gives hydrogen gas plus oxygen gas. Change of color. When green-colored copper carbonate is heated, evolution of carbon dioxide occurs and black copper oxide is left. Copper carbonate, green, gives copper oxide, black, plus carbon dioxide. Formation of precipitate. When two chemicals in solution form react, an insoluble substance is formed. It settles down as a precipitate. For example, silver nitrate solution is added to sodium chloride solution. Silver chloride is formed as white precipitate. Sodium chloride plus silver nitrate gives silver chloride plus sodium nitrate as precipitate. Change of energy. Chemical change involves change of energy. That is, the change occurs either by absorption of energy or by evolution of energy. If energy is absorbed, the changer is called endothermic, or if energy is evolved, it is called exothermic. These changes are explained taking some examples. Endothermic change. An endothermic change is a chemical reaction in which the heat is absorbed. To convert milk to curd, the milk is made lukewarm, that is, heat is given to it. So, it is an endothermic change. Exothermic change. A chemical reaction causing the release of heat is called exothermic reaction. For example, burns a paper release heat. When fuel burns, it gives out heat and light. So it is an exothermic change. Rusting of iron. Some decorative pieces when new are shiny, but slowly they get green color coating on them. You have grills, doors, etc. in your house. If they are not painted, they get a brown layer over them. The first shiny metal is copper. When it is exposed to moist air, it reacts with it and forms a layer of copper hydroxide and copper carbonate on it, which is green in color. Second metal is iron. When it is exposed to moist air, it reacts with it to form iron oxide and iron hydroxide. They are brown in color. This type of reaction in which metals react with moist air and develop and layer on them is called corrosion. Corrosion of iron is called rusting. During rusting, chemical reactions occur on the upper layer of metal and is eaten up. You might have seen some iron objects lying outside which develop holes in them. Iron plus oxygen plus water gives iron oxide plus iron hydroxide. Rusting can harm iron grills, doors, etc. They should be protected because they are costly and cannot be replaced easily. Factors affecting rusting. There are several factors that assist and accelerate the process of rusting. Some of them are moisture. Iron exposed to rains is the most common reason. Acid. It accelerates rusting. When exposed to acid rains, iron rusts faster. On the other hand, alkalis inhibit rusting. Salt. Iron tends to rust faster in sea due to the presence of salt. Impurity. Pure iron rusts lower than the iron mass, which contains a mixture of metals. How to protect iron from rusting? Rusting can be prevented by any of these methods. In rainy season, your bicycle also produces sound. The chain and the rim develop brown layer. To decrease the sound, apply grease or oil on them. This is called greasing. How are the grills, railings, etc. protected? It is done by painting them. This is called galvanization. Paint contains zinc metal, which is more reactive than iron. Zinc forms the upper layer, reacts with moisture air, and iron is protected. The huge ships sail in seawater. Ships are made of iron and seawater has salts in it. Salts increase rusting. So even if the ship is painted frequently, it gets rusted and we have to replace its parts from time to time. Metals can be made by alloy formation. Two or more metals are mixed to make an alloy. Stainless steel is an alloy. Crystallization, the process of deriving large crystals of pure substance from their solutions, is known as crystallization. It is a physical change. Crystals of salt are obtained by the evaporation of seawater. When a solid substance is mixed with a liquid and stirred, it dissolves in the fluid. When we keep on adding more and more solid to the liquid, a point comes after which no more solid can be dissolved in the liquid. This point is known as the saturation point, and the solution is called a saturated solution. In this technique, the solvent molecules apart from the solution is heated in an open container. On cooling the solution, the dissolved solids come out of the solution and crystals of solute start accumulating on the surface of the solution. Now these crystals can be collected and dried as per the requirement of the product. If a solid is not dissolved in the liquid and is simply mixed in it, then it can be separated by the process of filtration. The size of crystals formed during this process depends on the cooling rate. If the solution is cooled at a fast rate, then it forms a large number of tiny crystals. Large crystals are formed at slow cooling rates. Application of crystallization. Purification of seawater. Separation of alum crystals from impure samples. In the pharmaceutical industry, crystallization is used as a separation and purification process for the synthesis and isolation of many useful substances.